So let's look at some probability questions. When we are eating buffalo wings, we assume that each buffalo wing is independent. What that means is that whether the taste of one buffalo wing has no bearing on the taste of another buffalo wing. So there's an 85% chance, or rather 0.85 probability that each wing is delicious. What is the probability that all four of them are delicious? Since they're independent, that means we can take each individual probability and multiply together, and that's going to be a 0.522. So what is the probability eating these four wings that the first two are not delicious and the last two are delicious? Well, if there's a 0.85 chance of a wing being very delicious, that means 1 minus 0.85 gives us a 0.15 chance that it is not. So if the first two are not delicious, that carries a 0.15 chance for each wing. Since the next two are delicious in this scenario, that carries a 0.85 chance for each wing. Multiply all of this together, and we get a probability of 0.016. Pretty low. Number 8 gives us percentages after a survey. 78% of people have seen The Dark Knight. And if they have seen the movie The Dark Knight, an excellent movie, there's a follow-up question: have you seen The Dark Knight Rises? It's the next movie in that trilogy. And of the people that have seen it, 89% have seen the next movie. So if we were to pick someone at random, if we were to choose a person at random from this study, what is the probability that they have seen The Dark Knight and also The Dark Knight Rises? Again, 78% of the people have seen The Dark Knight, and 89% of these 78 have seen Dark Knight Rises. So not everyone has seen both. Not everyone has seen, some have seen one, some have seen the other, some have seen none of them, right? So let's write this out. The probability that someone has seen The Dark Knight is equal to 0.78. And what this next sentence says here is that of the people that have seen The Dark Knight, given they have seen The Dark Knight, what is the probability they have seen The Dark Knight Rises? That is 0.89. So being able to calculate the probability that someone has seen The Dark Knight and seen The Dark Knight Rises, that's going to be the probability they've seen The Dark Knight, 0.78, times the probability they have seen The Dark Knight Rises given they have seen The Dark Knight. That's because these two events are not independent. And that's going to be 0.6942. Next up is the OR statement. We have 30 chocolates with peanuts, 23 with caramel in a box of 50. Right? 10 of these chocolates that have peanuts also have caramel. So what is the probability that you randomly choose a chocolate and it has caramel or it has peanuts? Not and, or. That means if it has caramel alone, it counts as successful. If it has peanuts alone, it counts as successful. And obviously if it has both of them, then it counts as successful. Now since there is an overlap of caramel with peanuts, we're going to use the OR statement formula. The probability of a chocolate containing caramel plus the probability of a chocolate containing peanuts minus their intersection, the probability that they contain both. That's because there are 10 chocolates that have both caramel and peanuts. And those 10 are included in this 30 and also included in this 23. Since they are double counted, that means we have to subtract out one of these 10, one set. So 30 plus 23 minus 10 all over 50 is going to equal 43 over 50. That should be a 50, not a 10. I don't know why that says 10. So 43 over 50.